Hello everyone, welcome to my YouTube channel. Today we're going to discuss about 9701, Summer 23, question paper 21, question 3, 4 and 5. I have already solved this paper before, question number 1 and question number 2, so you can see my video. So this is a very important paper. Look at the question number 3. Chlorine is a very reactive element. Chlorine reacts with the silicon to form silicon 4 chloride. So we will get silicon 4 chloride. Describe the appearance of silicon 4 chloride at room temperature and pressure. State its structure and bonding. Silicon 4 chloride is a structure like that, in which one silicon is covalently bonded with 4 chlorine atom. So the appearance of this substance is that this is the colorless solid. And structure and bonding, as you can see that there is a covalent bond between silicon and chlorine. So this is a simple covalent structure. So this is a simple covalent. So these are the uh, regarding appearance and structure and bonding. Then sample of magnesium chloride. We have two substances, magnesium chloride and phosphorus 5 chloride. This is phosphorus 5 chloride are added to the separate beakers of the cold water. Complete table 3.1. Ignore temperature changes when considering observations for the two reactions. So appearance at room temperature. So we're going to uh, write down the appearance of these two substances at room temperature. Magnesium chloride, this is an ionic compound, and ionic compound, mostly they are solid. So this is a white solid at a room temperature. And phosphorus 5 chloride is a pale yellow solid. This is a pale yellow solid. One similarity in observations on addition to the cold water. So if we dissolve MgCl2 in the water, we'll get a colorless solution because there is no reaction. Only magnesium chloride dissolves in water to make colorless solution. So it will form a colorless solution. In the case of PCl5, when PCl5, if it is added into the water, it reacts with water to form the substances like H3PO4 plus HCl. As we're getting the two acids, aqueous solutions of two acids, and these are also colorless. So we will get the colorless solutions in both the cases. So these are the two similarities. One difference in observation on adding to the cold water. Okay, so when we react the magnesium chloride, or when we dissolve the magnesium chloride in the water, because there is no reaction, then we only get the colorless solution. But in the case of PCl5, the first oxidation state, the first physical state of this substance is a gas. So we'll get white misty fumes or the steamy fumes of HCl. So in the case of PCl5, steamy fumes, but in the case of magnesium chloride, no steamy fumes, only colorless solution. pH of the final solution. In the case of PCl5, we are getting H3PO4 and hydrochloric acid. So mostly they are the strong acids, and you can write the any pH before 3 or 4. So if we write 1, it's okay, or 2, it's okay. Then pH of the final solution, it will form a slightly, you can say the acidic solution when we dissolve the MgCl2 in the water. Then the pH value is approximately 6.5. Then state the reagent and the conditions required for the formation of sodium chlorate 5 from Cl2. Sodium chlorate 5 is NaClO3. So NaClO3 that can be produced from the chlorine when chlorine reacts with hot and concentrated sodium hydroxide. So hot and concentrated sodium hydroxide that reacts with chlorine to form this substance. So this is hot and concentrated. So sodium chlorate 5, then sodium chloride, then water. So these are the three products which we may get when chlorine is reacted with the hot and concentrated sodium hydroxide. If we replace it with the cold and dilute sodium hydroxide, we will get sodium chlorate 1, which is NaClO. So just change the one product. Instead of making NaClO3, we will get sodium chlorate 1 when we use the cold and dilute sodium hydroxide. So the answer is that sodium chlorate 5, NaClO3, that will form when we react the chlorine with hot and concentrated sodium hydroxide. C2 explain why the reaction in C1 is described as a disproportionate reaction. So your answer should refer to the relevant species and their oxidation state. So this is a little bit difficult question here because these two parts are difficult. So if a student, he or she will not be able to solve C1, it's very difficult to predict the oxidation state or predict about the nature as a disproportionate reaction. So this chlorine is 0. Here the chlorine is -1, and because sodium chlorate 5, so the oxidation state of chlorine is 5. So the rest of the elements like sodium is +1 here, +1 here, chlorine, oxygen is -2, +1 hydrogen, then -2 and +1, -2. So it means that only the oxidation state of chlorine changes from 0 to -1 and 0 to +5. So whenever the same species is both oxidized and reduced, that reaction is disproportionate reaction. So we can say only the chlorine is both oxidized, oxidized mean from 0 to +5 and reduced from 0 to -1 simultaneously. So when same species both oxidized and reduced in a chemical reaction, that reaction is disproportionate reaction. Then the next part is chlorine reacts with the methane in a series of reactions to produce chloroalkanes. State the conditions required for the chlorine to react with the methane. The reaction between methane and chlorine to form different halogen alkanes is a free radical substitution reaction. And this is a photochemical reaction, so it only happens when the UV light is there. So the condition is ultraviolet light. One of the products of the reaction is CH2Cl2, which reacts further to produce CHCl3. There are series of reaction if we replace the one hydrogen or we'll substitute one hydrogen with the one chlorine. The first product which we may get, that is a CH3Cl, then HCl, then replace another hydrogen with chlorine. So we will get CH2Cl2, then we will get CH3, CHCl3, and then CCl4. So these are the substituted products which we may get when methane reacts with the chlorine in the presence of UV light. As we are getting this product, CH2Cl2. So this CH2Cl2, which reacts further to produce CHCl3, as you can see that we will also get CHCl3. So these are the four substituted products. Complete table 3.2 to show details of the mechanism that forms a CHCl3 from CHCl2. Now, this is a free radical substitution. So there are three steps. One is the initiation, then propagation, and then termination. So in initiation, there is a homolytic variant between the two chlorine atoms, which are joined to form chlorine molecule. So this is the initiation in which the chlorine is in the presence of UV light. It is split up homolytically to form free radicals of chlorine. So you will get the free radicals of chlorine by the homolytic chain of chlorine. So propagation is the combination of a free radical and a molecule. So CH2Cl2, if it combines with the free radical which is obtained from the initiation, the free radical will be changed into a molecule. So if this free radical combines with the H, this CH2Cl2 has a bond like this. There's a one carbon and two hydrogen atoms, then two chlorine atoms. So if this bond is broken homolytically, we will get a substance like CH, then Cl2. We'll get CHCl2. This will be a free radical, and the hydrogen combines with the chlorine to make HCl. So this free radical will be changed into molecule, and the molecule will be changed into free radical. Termination is the combination of free radicals. Now we have different type of free radical, like this is another free radical, this is also a free radical. So if we combine the free radical, we will get this CHCl3. We're going to form CHCl3. So CHCl3 that can be formed by combining these two free radicals, CHCl2, this is a free radical, and then if we add just one more free radical, so we'll get CHCl3. So these are the three steps during the free radical substitution of alkane in the presence of UV light. Now there is further reaction that CHCl3 and HF are used to form this. So these are the two reactants, CHCl3 and then HF, and one of the product is CHClF2, and we have to predict another product, and then we have to balance the chemical equation as well. So there are two fluorine on the right hand side. The product is already given. So if we put two here to balance this fluorine, now there are two fluorine atom. Now there's two fluorine atom are covered, then one chlorine is there. It means that two chlorines are there, and then three hydrogens are there on the left hand side. So one hydrogen is there. So two hydrogens are there. So mean two hydrogen and two chlorine, they can be represented like 2HCl. So this is the balanced chemical equation. Now, in the next part, X is the product of the substitution reaction that occurs when CHClF2 reacts with the bromine. There's only one naturally occurring isotope of fluorine, which is F19. The mass spectrum of X shows molecular ion peak, which is at 164, 166, and 168. Complete table 3.3 to show all the molecular ion peaks for each peak. Now there are different possibilities. So formula of the molecular ions, we have the mass per charge values 164, 166, and 168. There is an idea in this question as well that 168 peak is due to the CF2, CLBR. So CF2, we can write CF2 because there is no change in CF2. So we can copy the CF2, so CF2 here and then CF2 here. Now, all the molecular ion, they contain chlorine and bromine. Okay, chlorine and bromine. Then this also contains chlorine and bromine are unipositive ions. So you can make a unipositive ion. Now, if we look at the MR, now 37 plus 81, we're getting 168. So this is 166. So we have to reduce just two number. So if we replace the bromine, another isotope of bromine, like we keep the chlorine as a 37. And if we replace this bromine with 79, we can reduce two number. And if we reduce two number, we'll get 166. So this molecular ion is responsible to peak at 166. Again, we can reduce two numbers here because bromine has two isotopes, 79 and 81. We have already shown. Now we know that the chlorine has also two isotopes, 37 and 35. So just copy the number 79 because we have to reduce two more number to get 164. and replace the chlorine 35 with 37 with 35. So we'll get the answer. So these are the two molecular ions which are responsible to give peak at 164 and 166. Then question number 4. V is a colorless liquid. Now, this is a colorless liquid. It contains two functional groups. This is alkene, and this functional group is carboxylic acid. Now, V reacts with an excess of LiAlH4. LiAlH4 is a reducing agent, and reducing agent is a hydrogen donor. So just look at the question, draw the structure of W in the box. V reacts with an X. Okay, now this is a V which contains two functional group alkene and carboxylic acid. Now this is a carboxylic acid. So when we add the excess of LiAlH4, the carboxylic acid is reduced to aldehyde, and then because we have the excess of reducing agent, aldehyde will be reduced into primary alcohol. So as primary alcohol is oxidized to aldehyde and aldehyde is oxidized to carboxylic acid, so carboxylic acid can be reduced to aldehyde and aldehyde into primary alcohol because we have excess of LiAlH4. So if you want to convert this structure into primary alcohol, just to remove this part of the carboxylic acid, you will get the primary alcohol. So we can draw the structure of primary alcohol. Just copy this structure. There's a double bond. Okay. And then show the OH. So this is the structure of alcohol, which can be obtained when this V reacts with the excess of LiAlH4, which is a reducing agent. Then identify the role of L. This role of LiAlH4 is it is a reducing agent. It causes the reduction of the carboxylic acid but oxidizes itself. V reacts to form Z. This is a V, this is a Z in a single reaction as shown. As you can see that the carboxylic acid part is the same. There is no change in this part. But the alkene part, alkene is converted into diol. So alkene can react with acidified KMnO4 in two ways. If we use the cold and dilute acidified KMnO4, then we will get diol, and hot and concentrated, then there must be a oxidation of this double bond. So as we're getting the diol, so that's where the reagent that is used to convert V to Z, it must be KMnO4, but cold and dilute KMnO4. Cold and dilute KMnO4. Deduce the empirical formula of the C. So first of all, just have a look on the molecular formula. This part is CH2. This is CH. This is CH2. This is C. So just count the carbon atom. 1, 2, 3, 4. So there are 4 carbon atoms. Then count the oxygen. 1, 2, 3, 4. There are 4 oxygen. How many hydrogen atoms are there? 2, 3, 4, 5, 6, 7, 8. So there are 8 hydrogen atoms. This is the molecular formula. This is not the empirical formula. So you can convert the molecular formula into empirical formula. If you simplify this formula, 4 ratio 8 ratio 4, so it will come 1 ratio 2 ratio 1. So this will be the empirical formula. Then the next part is about the hybridization. So complete the table 4.1 to show the number of sp2 and sp3 hybridized carbon atoms. Sp2 hybridized mean the molecule or the carbon must have a 3 electronic region. It must have a 3 electronic regions. So just check the electronic regions. sp3 mean 4 electronic region. 4 electronic regions. Now, if we look at the V, we can say that okay, now V is this. Okay, now this double bond, it is this double bond is like this. Okay, so here is the hydrogen as well. Here is hydrogen, hydrogen. So this carbon is sp2 hybridized because it contains 3 electronic region. So this is sp2. This is also sp2. This carbon is also with 3 electronic regions. So this is also sp2. So there are 3 sp2 hybridized carbon. And this carbon is actually contains 2 hydrogen as well. So 1, 2, 3, 4. There are 4 electronic regions. So this carbon is sp3 hybridized. So there is just one carbon, which is sp3, and 3 carbon, which are sp2 hybridized. So we can write that sp2 hybridized carbon are 3 and sp3 1. Now, in the part C, Q contains the elements carbon, hydrogen, and oxygen. So this is the compound which contains 3 elements. It is a saturated molecule, mean there is no double covalent bond between carbon to carbon. All the carbon bonds are single. No branch, there is no branch, it is a straight chain carbon. Q contains only one functional group. There is no extra functional group. Double bond is not there. There is one just functional group. The relative molecular mass, this is the MR of this Q. No effervescence is seen when sodium carbonate is added to this. It means that the carboxylic acid is not there because the sodium carbonate can produce the carbon dioxide. Effervescence of carbon dioxide with acid, so there is no acid. Effervescence is seen when sodium is added to the Q. So this is the property of alcohol because alcohol can produce the effervescence of hydrogen with the sodium metal, with the reactive metal. Then Q reacts with the alkaline iodine to form a yellow precipitate. This is a iodoform test. So iodoform test confirms the presence of either the methyl ketone CH3C double bond O. As we can see that when sodium is added, we're getting the effervescence. It means ketone there must not be there. So this is not the case. And the second thing is that it is also used to identify the CH3CHOH, which is almost the, you can see the secondary alcohol the most cases, but this is the unit, it must be there. CH3CHOH. So it means that we can say that the Q, it must contain CH3CH and then OH. It must contain this part. Now, as we can see that CH3CHOH, there must be this unit must be there. Now MR is there. 88 is the MR. So if we look at the carbon, hydrogen, and oxygen, this unit, that what is the MR of this unit? There are 2 carbon and then 1, 2, 3, 4, 5, 5 hydrogens. So 2 carbon, then 5 hydrogen, then 1 oxygen. So this is 24 plus 5 plus 16. So it is 45. So MR is 88. So 88 minus 45. This is 43. As we can see that the no branch is there. So it means that all the carbon are in a straight line. So we can say that 43. Okay. Now, if we add just one CH3, the MR of CH3 is 15. If we add 2 carbon mean 5 hydrogen must be there. The MR is 29. And if we add the length of 3 carbon, C3H7, the MR is 43. So it means that we can add the 3 carbon here. Okay, so this is CH2, then CH2, and then CH3. So you can draw the skeletal formula with the 1, 2, 3, 4, 5. There must be the 5 carbon atom, 2, 3, 4, 5. And on this carbon or in this carbon, you can show the alcohol group. So this is the structure of Q. It contains carbon, hydrogen, oxygen. It is a secondary alcohol. There is no branch in this, cannot produce the effervescence with the sodium carbonate, but can produce the effervescence with uh, sodium metal, reactive metal, and it contains the group CH3CHOH. This is the part CH3CHOH, which will give the positive iodoform test with alkaline aqueous iodine. Then, next question. Next question is that the molecule M is present in petrol, a fuel used in cars. M is a saturated, contains single covalent bond between carbon to carbon, non-cyclic hydrocarbons. If you have the cyclic, then you will have to apply CnH2n general formula, which is the general formula of cycloalkanes and alkene as well. This is saturated if it contains single covalent bond, and if it is non-cyclic, it means you have to apply the general formula CnH2n plus 2. M contains 8 carbon atoms. So if there are 8 carbon atoms, so there must be 8 times 2, 16 plus 2, 18. So M is actually C8H18. Construct an equation for the complete combustion. In complete combustion, you will get carbon dioxide. So you have to make carbon dioxide combustion in the presence of oxygen. If we make carbon dioxide, the extra product is water. So carbon dioxide and water, these are the two products. Then you have to balance this equation. There are 8 carbons, so you can put 8 here. Then 18 hydrogen, you can put 9 here. So 16 plus 9, 25. Then you can balance this as a 12 and half, which becomes 25. So this is the balanced chemical equation. Describe how the composition of a product differ when incomplete combustion. If there is an incomplete combustion, we will get carbon monoxide instead of carbon dioxide, or we can say carbon monoxide along with the carbon dioxide. And if we reduce more air, we can get the uh, carbon as well, carbon soot. So carbon monoxide or carbon soot, they make the two products. So we'll get the carbon monoxide or carbon soot. And definitely, because the amount of the oxygen is insufficient, which is a limiting reagent in this case. So all the fuel will not be able to burn, or there is no complete combustion. So you may get the unburned hydrocarbon. You may get the unburned hydrocarbons as well. Or sometimes you can also say that there must be a less amount of carbon dioxide as well. Amount of carbon dioxide as well. Now, in the B part, when petrol is burnt in an internal combustion engine, oxides of nitrogen, according to your specification, there are two oxides of nitrogen, NO1 and NO2, released into the atmosphere. Oxides of nitrogen are responsible for the formation of acid rain. They are further combined to get acid rain. Suggest the conditions required for the production of oxides of nitrogen during the combustion of M in an internal combustion engine. In internal combustion engine, there is a high temperature. So use an appropriate equation in your answer. So actually, at high temperature, and you can say at high temperature and pressure, nitrogen reacts with the oxygen to form nitrogen monoxide. So you can balance this equation like this. Or you can also say that the nitrogen, it can also combine with the oxygen to make nitrogen dioxide. So you can balance accordingly. So these are the two oxides which you may get when nitrogen reacts with the oxygen at high temperature and pressure in the internal combustion engine. Then describe how acid rain is formed from the formed in the atmosphere in the presence of oxides of nitrogen and sulfur dioxide. Identify the role of oxides of nitrogen in this process and include all. Oxides of nitrogen, NO2 especially, that is used as a catalyst. So the reaction between NO2 and SO2 is that it will give us SO3 plus NO, and NO reacts with the oxygen to form NO2. As we are getting NO2 again, so we can say that NO2 acts as a catalyst. This acts as a catalyst. Secondly, we have to explain that how acid rain is formed. So now we have the two oxides of one is the oxide of sulfur and another is the oxide of nitrogen. So SO3, it combines with the water to get acid. So H2SO4 becomes the part of rain. Then NO2 also dissolves in water or in the presence of air to make nitric acid. Or we can say NO2, when it dissolves only in water, it can also make HNO2. So these are the acids like sulfuric acid, nitric acid, and nitrous acid. They become the part of rain. So we can say these reactions are actually responsible to make acid rain. State one other type of air pollution that is caused by the production of oxides of nitrogen in an internal combustion engine, that is the photochemical smoke. Then this is another part. C, biodiesel. T is a fuel made from vegetable oil. R, this is the vegetable oil. It contains C double bond OO, and it contains the ester linkage. Shows the production of P from R in a two-step process. Now this R in the step one, it is changed into a carboxylic acid and another product. Okay, and in step two, this carboxylic acid, it reacts to form ester again. And concentrated sulfuric acid is used, and we have to predict the G as well, and we have to draw the structure of J as well. And now, if this because this ester is formed by the combination of alcohol and the carboxylic acid, as we can see that these three carbons are attached with each other. So we have three carboxylic acid molecules and just one molecule of alcohol. So if we break this bond from here and just add hydrogen here, so we'll get the structure of J, because we have already have the structure of carboxylic acid. This is the carboxylic acid. You are getting the three molecules, but the structure is same. So that's why this is L, and the J is like this is 1, 2, 3 propane, and three alcohol groups are there. So this is propane 1, 2, 3 triol. Propane 1, 2, 3 triol. So if we draw the structure of this, you must have a three carbon atom. So 1, 2, 3. You have the three carbon atom. One alcohol is here. One alcohol is here, and the third alcohol is here. So this is propane 1, 2, 3 triol. Now this carboxylic acid combines with another G to get this type of product. As you can see that this part of the molecule is same. So just identify this part. So the acid is same. So it means that if we react with the CH3OH, then we will get this product. So CH3OH is actually the reagent G, and CH3OH is methanol. So methanol is used along with the concentrated sulfuric acid to make ester again. I draw the structure of J in the box. We have already done that. Name the type of reaction that occurs in step 2. This is step 2. We are getting the ester. So esterification is their mean condensation. So this is condensation. Name organic reagents G used in the step 2. Yeah, organic reagent G is methanol. Yes, and this is methanol. And this is talking about the step 1. So in step 1, all three esters group in R react. Suggest a suitable reagent in the condition for step 1. In step 1, we can use the acid dilute because we are getting the esters. We can use the dilute uh, sulfuric acid for the esterification. Okay, then uh, you can take the idea dilute or concentrated. You can also say the concentrated here, the concentrated sulfuric acid or dilute sulfuric acid. Now, L is called decanoic acid. Use systematic nomenclature to deduce the name of the tea. Okay, name of the tea. Okay, this is ester. Normally, if we have, let me tell you the idea. If we have a substance like this, okay, so to get the name of the ester, first of all, just copy the name of the alcohol. This contains two carbons, so this is eth, and it comes from ethyl. So this is ethyl. Then how many carbon atoms are there? Two carbon atoms. So this is ethanoate. Ethanoate. Now the alcohol is in this compound. The name of this ester was ethyl ethanoate. Now we are using the methyl as a alcohol, and there are 10 carbon, 8, 9, 10. And there are 10 carbon atoms. So convert the methanol to methyl, and there are 10 carbon atom, deck, single bond, and then ending code A, technoate, methyl technoate. So methyl technoate will be the substance which we may get at the end of the chemical reaction. So this is all about the paper 970121, May, June 23. I hope this paper will help you before your examination. And don't forget to subscribe my channel. If you subscribe, you will get the latest paper on my channel. Thank you.